everyone. Happy to see you all present for that webinar on the colorization feature. So here is what we're going to talk about today. So a little bit about the colorization feature. Obviously, we'll go through a live demo. We'll talk about some key features of the cloud that we released recently. So just do a quick round of a review of what was recently shared, and in the end, Gail will take over and talk about a few general cloud use cases, and also talk about how you can get started. And we'll finish up with a Q&A, obviously. So I'm going to get started with the colorization. So this feature is actually a cloud processing feature. So it's very important that you keep that in mind. It's a feature that is here to colorize data sets and produce what you see here on the screen. On the right, a texturized mesh or a textured mesh, and on the left, a colorized point cloud. And basically, this feature is going to change drastically the way you look at your data. So today you're used to look at data this way, and what you are going to be able to produce in the future is something that looks like this. And this is drastically going to change the way you review your data, and people in general can look at data. So why would one want to colorize a data set? The first reason, and that's probably the most obvious one, it's because point clouds are very hard to read. Not everyone is used to visualize point clouds. Here's an example, and that's mostly what we were able to produce at the beginning of Elios 3, and this is hard to read. So even if you apply some optimization, give some transparency, clean out a bit the point cloud, it's still not very easy to read. And then when you start to turn a point cloud into a mesh, you start to see that now there is a gallery connecting to another one. There are walls. There seems to be a bit of dirt here. And when you add texture, you realize that you are inside the mine, that there are some metallic grid on the ceiling. You can see some of the texture of the rock, and it completely changes the way you look at data. So this is a summary, of the progression between all the steps. Now, another thing which is also very interesting is when you get a point cloud like this, you're missing some context, which will help you extract insights, typically like measurements. So what we're looking at actually is spalling inside a pipe in a dam, and you can see here that's the type of view we had in the past, where we would try to measure, matching the video and the point cloud, try to measure an area of spalling, which we could see in the video, but not in the 3D view. And on the right, you can see that we were off by a good area of measurement when trying to assess the extent of this defect. But we'll talk about this use case a bit later. Another thing, it's the lack of information, which is the location of data. So typically in an asset, you want to find some stuff in your assets which are only visible in the video. So unless you manage to place points of interest along the path at the right place, you're unable to localize something like this very easily unless you go through the video again. And here again, it's colorizing your data, add some context, which really help you go through a known place and find back some information, some visual information that you know about, that you've seen during an inspection, or that you know because you've been into this asset before. And this is really adding a lot of context. So summarizing the value proposition of that new feature, obviously it's bringing to you guys the depth of information which is delivered by colors. And that's specifically done for indoor data sets. As you might or might not know, indoor reconstruction colorization is very difficult, and we're a bit, let's say, behind the outdoor world. But finally, we have it, and we're able to bring it to you today. Obviously, what we want is bring you with a better understanding of what you're looking at, especially when you share data with other colleagues, with clients. This is really something that is extremely useful. Being able to extract insight, that's only possible when you combine the 3D model with images from the video. Save time searching for things that you know, that you have in mind, that you've seen before. And eventually, I was talking about the outdoor world. The industry is expecting now results like this and deliverable like this because they've been accustomed to colorized point cloud and meshes from outdoor data sets. So it's also something that is more and more requested by end customers who are expecting that in their deliverables. Now, let's talk about what it's not. I think it's pretty important to set expectation. So this is not a tool that will allow you to detect ultra-fine cracks like you see on this animation, because the mesh we produce has a resolution of 10 centimeter voxels, which means that the 3D world is represented with triangles that are 10 centimeter big. So we don't go into as much detail as typically a photogrammetric model that you see here on the right. It doesn't also render a full uniform asset. You will only get what gets into the field of view. So it's important that you plan your flight path so that you get the information you're looking for. But the good thing is this algorithm that we have always works. So you will always get a 3D model at the end. The quality of it will depend on how you perform your flight, but you will always get the result. And finally, I've mentioned it briefly, but high detail environment with very small objects like wires, pipes, cables, stairs, they don't render very well because every object which is below 20 centimeter in size will not be reconstructed correctly because there won't be enough points to represent it into the real world. So this is important to keep in mind. Now, I think we've talked enough about the colorization algorithm, and I suggest we jump into a demo. So I hope you now see again my screen and see the cloud. So this is an asset which has been shared kindly by a company called Canzol in Germany. They're inspecting sewer, and they've been inspecting this specific gallery. And here, they wanted to make sure they are able to measure a lot of points. So here I'm going to first bring the colorized point cloud. So here I've activated the point cloud layer of one specific flight, and I will enable now the colors directly in the point cloud. And what you see here is that we're able to visualize the asset now with colors. So this is the first step, which can be interesting because some of the objects which would not render in the mesh would still have some consistency here. Typically those lamps, they have some shapes. You can see that some points are used to represent the volume of those lamps, which in the mesh would be slightly different. And now I'm going to pull up the mesh layer. And here we go. This is the mesh. So you see here the lamp again, but it doesn't necessarily have a huge volume here. But then the precision and the rendering of the information is really, really good. And I'm going to jump directly to a point of interest that I have here, which is here on the wall. And we're looking at a connecting pipe here on the wall. And now you can start to see a lot more details about this pipe. We can see that it's connecting from the top. And if I remove the mesh, just so you get a comparison, let me go back to the normal visualization. So here you see that there is something on the wall. You can guess that there's something here, but you don't have any details, and you're unable to start to measure exactly at which height it would start, for example. So here, when I bring the mesh layer, it's a very different thing. So I can start to turn on my measurement tool, navigate close to the lower part of the pipe, and maybe try to measure what's the distance to the ground. So I see it's 2.6 meter up the ground. And those are things that you would not be able to do if you do it directly from the point cloud. You're lacking some very important information to do that. Another example, here it's a dam that I was talking about. And here I'm just going to show you the type of result you can get from the mesh. So here I'm activating the mesh layer, and I'm going to, navigate into the model. There we go. And here you see the results. So you have really the ability to see all the concretes and the features and the different sections of concrete, even down the penstock pipe that is here. And what's important here is to look at the flight path. So if I take some distance, you see that there's not necessarily a lot of engineering inside the flight path. We just went down the pipe and up and landed back onto the starting point. And that's it. And this is what it took to produce that model, just a simple flight back and forth, and then a bit of processing, and we get that. A last example, which I think is really interesting, is about mostly about the colorized point cloud. So I'm going to bring again here the colors here. I'm going to remove the inspection map. So it's very important to understand that what we colorize are the individual map of each flights and not the inspection map, which is the aggregation of all the flights into a single map. So here you can see all the different point clouds together, and we start to notice what this asset is. It's actually an abandoned castle, I would say. You see the tiling of the roof on this end. You see there's a lot of vegetation inside the different section of this building. You can also see, and here again, the difference between the mesh and the point cloud. You see that there's a beam structure right here that is left. These are typically things that would not render very well into the mesh, but that you have in the point cloud. So the combination of those two layers can be very important and useful when you're navigating that kind of assets. So that gives you a quick overview of the feature and a quick demo. You can see that the colorization is brought here into this menu. That's how and where you can start the colorization. And it's simply about turning on and off some layers to display. But let's go back to the presentation and talk a little bit about how this algorithm works. So we're not using photogrammetry, and a lot of people think we are, but we're not. And I want to make a quick comment. This is a mesh. This is not a photogrammetric result, right? It's a mesh. And the difference between our algorithm and photogrammetry is very simple. So if you're familiar with photogrammetry, what you have to do is capture a lot of image with a good overlap, so that eventually the algorithm is able to find common points between images, and using triangulation, it's able to rebuild the 3D world. So that's what photogrammetry does. And eventually, when it has enough points, it's able to extract textures from images and place them onto the 3D model to build a textured mesh. Our algorithm is a lot more simple. We just capture, as we do usually, a point cloud and a video. And what we do is we turn that point cloud into a mesh. That's the first step. And once we get that, we just look at the different voxel, which are the components of a mesh, and see if there is a place or a position where there is this voxel is in the field of view of the camera, and we create texture out of the video, which we place onto the mesh. So it's a lot more simple. There's no big processing of the point cloud itself. It's just turning into a mesh and generating textures for it. And the reason we went for that is because, first of all, there's pros and cons, obviously. And here we see again a photogrammetric model on the right. So photogrammetry provides very high precision, sometimes down to millimeters. That's what some photogrammetric providers are saying, that they can go down to millimeter. And it's less subject to drift because you extract features from images where position is usually well known, and you can build a model. But it's very time consuming. If you want to get a model like this, you need to go and have an 80% overlap of images horizontally and probably as much vertically. So it means that you have to cover this wall with hundreds and hundreds of pictures until you can get that sort of model. And most importantly, you need to have very, very high quality images with very consistent lighting and exposure, so that the software can find those points of interest, those common points, let's say, between images, and rebuild that model. In our case, what we do is we don't necessarily have a specific path to follow. It's a lot faster to capture data. It's not dependent on image overlap. You don't need to think about that. It's also less dependent on the image quality. So obviously, the better the image, the better the results. But if you do not have good images, you will always get a model. It's just that it will not necessarily be of the highest quality. But on the opposite, we have a limited resolution into the mesh because we have voxels of 10 centimeter, and we are subject to the drift of the flyover algorithm. However, in the images that we use are directly extracted from the video. So the images that we use for the texture, they're directly extracted from the video. So the precision you get inside the image will be reflected directly in the model. So if you get very close and get down to a millimeter per pixel, that's exactly what you will find in the model inside the texture. And that's very important to understand the difference between the texture and the model itself. Now, how does the workflow go? So simply you capture data with Elios 3 and Cockpit. You push that into Inspector. So Inspector is still going to be your way to go to extract information from the Elios. Then you have to push it to the cloud, and this is where the processing is happening. So why do we process things in the cloud? It's because in the cloud, we have unlimited memory and processing power. So even though the processing is fast and it's much faster than photogrammetry, it still requires significant amount of memory and CPU to produce the results. So this is why we chose to make it a cloud-based feature so that we can serve that feature to the maximum amount of client and not be dependent on client's computer. Then once the process is done, you can visualize that information inside the cloud. So we've seen that. You can also download the mesh or the colorized point cloud right onto your computer from the cloud. But you can also synchronize the information back to Inspector if you want to further review the data on your desktop inside Inspector. So this is typically possible. And you can obviously access the file locally on your computer like you would access any other file from Inspector. And something very important to remind is that your client, they will get access to the colorized point cloud and mesh if you share the data directly from the cloud. Now, obviously, there are some limitations to the algorithm. So we'll go through those limitations, and this will give you a hint on when you can use it and when it's appropriate to use that algorithm. So the first limitation is, everything that gets into the field of view of the camera, if it's too small to be physically represented in the 3D world, will be projected onto the asset as a texture. So typically here, we flew with a UT probe on the drone, and it was constantly in the field of view. So you see the UT probe being projected in the texture all the way. So this is really important to keep in mind. Even if you have colleagues in the room, if they get in the field of view and this image gets selected to build a texture, you'll get your colleagues projected onto the wall in big size. So this can be quite daunting. The management of the camera is very important. Sometimes you can have some images that are burnt or overexposed, or on the opposite, underexposed. And these images might be used for texturing the mesh. So it's very important that you still keep an eye on the camera to make sure that you have a good image quality. You don't need consistent data quality between images. You sometimes can go a bit off with your camera, but it's good. It's better to have a good quality of image if you want to get a good result, obviously. Drift, this is inherent to the system that we have. So the SLAM algorithm, FlyAware, that runs on the Elios 3, accumulates some drift along an inspection, and it's possible that textures of a data set are taken from the way in or the way out, and there may be some drift between the two. So it's important that to keep in mind that some drift can be present in the model. Also, the camera tilt estimation can have some imprecision. So if you're moving the camera up and down constantly, you might end up with more drift into the texture. So this is something to keep in mind while you're capturing data, and be aware of this effect. And finally, I was talking about small objects. They do not render well into the mesh. So here you see a model with this ladder here, which appears very nicely into the point cloud. But as soon as I remove the point cloud and only look at the mesh, you see this ladder being projected onto the wall. And this is really because since we are averaging out the points and simplifying the model when we create the mesh from the point cloud, small objects are not rendered very well. So that explains a bit the limitation, and that tells you where and when to use this algorithm. So obviously, this works pretty nicely into a mining environment, inside a sewer. This was a chimney into a waste incinerator. So here you see the burner, and then there is a stack on top of it. So these environments have in common that they have large, near flat surfaces without any small object. And this is what makes them very well suited for that type of inspection. Now, you can have some small objects into those environments. Typically, having cables running inside that sewer would be typically possible. The only thing is just be aware that these small objects will appear as textures, and they don't necessarily will have any consistency in the 3D model. They will not be represented in 3D. So that's bad examples typically. That's where you should necessarily not necessarily use the algorithm. Typically in those very busy environment with a lot of small objects, pipes, staircase, handrails, all those objects, they do not render well. So just let's set expectations. And if you want to model, a room full of pipes, you will have some troubles, and you might be disappointed by the result. But it works well in a lot of other environments. So what are the industries that would benefit the most from this feature? Obviously, we've seen that water management and mining are very, very good environments for that. However, colorization, we think, brings a lot of value, contextual information to almost every Elios 3 user. You just have to be aware of the limitation. And with the current level of maturity, we're not able to get down to millimeter crack detection. So it might be less suited for structural engineering, for example. But still, we really encourage you to test out this feature and see if where it's fitted for your use case. Just a quick overview of data capture best practices. If you want to achieve something very good with your model, it's important that you dedicate one flight specifically to generate the texture mesh. That will ensure that you get the maximum coverage, and that you can follow, potentially an up and down scanning pattern if you want to maximize the quality of your model. Although this is not 100% required, you can fly normally and you will still get a model. But if you want to maximize the result, we also recommend to follow that sort of pattern. Keep the cage out of the field of view, and in general, any object, whether it's the UT probe or other objects, everything that gets in the field of view can be projected into a texture. But for the cage specifically, we can detect when the cage is in the field of view, and we discard those images from the model. So if you fly looking up all the way inside a chimney, for example, and you constantly have the cage in the field of view, we will discard all these images and you will end up with a hole into your mesh. I talked about the camera tilting, so try to avoid as much as possible the camera tilting. Do not carry the UT probe when you capture this mesh, and spend time hovering in front of key areas. So if you want to have a good resolution of a specific area, spend time in front of it so you get a chance to have very good results into your model. Again, ensure proper lighting and exposure. It doesn't have to be as precise as what you need for photogrammetry, but still, the better the quality, the better the model. And keep in mind, what you see in the video is what you get in the final model. So as long as you have that in mind, you should be fine with your model. So that's for the data capture best practices. I have a few success stories that I'd like to go through to show you some of the what our beta testers have been doing so far. So we talked about this measuring of a defect, and here basically the need was to assess or to characterize spalling into a pipe which is 200 meters long. So the defect was 200 meter inside this penstock pipe, so clearly inaccessible by humans unless you deploy massive means. And by using the mesh, we were able to pull out the surface measurement tool, which I will do in a moment, and assess the amount of concrete that was missing and be able to prepare the repair. So that's typically what you want to do here. So here you see, simply adding using the measurement tool, I'm able to get a surface. That's another interesting use case, although to be taken with a grain of salt. We had this client who went all the way to Chile from France, and they had inspected a gallery in a mine. And one of his colleague was in charge of bringing the paint to mark the ground control points on the walls. Unfortunately, the paint was not reflective, which means that you could not see those markings inside the point cloud, and they were not able to pick points to do the georeferencing of the model. Luckily, they had the capability to test the algorithm, so they generated the mesh, and they used the mesh specifically for that use case, and to be able to georeference the entire data set that they had. Now, keeping in mind that there are some drift into texture, it's very important that you have a very good model. And in this case, they really spent time not moving the camera at all, going very slowly and so on. And they ended up with a very good result that they could use for georeferencing. But this is showing, examples of things that you can potentially do with this feature. And finally, I think I mentioned, meeting the customer expectation. This is typically a case where this client needs to inspect 400 kilometers of sewers and deliver that type of results, a textured mesh that the end client, can virtually inspect and walk through. And the problem they had is that the current approach they have is to go down physically into those sections, and using an iPhone with a LiDAR, they were basically mapping the sewer this way. And they would get to a result that was not as good as this one. And they had to put people into a hazardous place, and it was long and tedious work to do. Now, luckily, there are Elios 3 users as well, and we could show them that in less than 5 minutes, they were able to get that sort of results with a very simple flight and a bit of time processing the data set. So this is, again, a very good use case showing the importance of such a feature. Now, I promised I was going to talk about a little bit what's new on the cloud, what we've released since the launch, because now it's been almost a year, a bit more than a year that we released this product. And I think a lot of things have been improved on this product, colorization being the last feature. But first of all, we now have the full editing capability on points of interest, which means you can create and you can edit POIs directly from the cloud. And this is very important because it enables a true collaboration between people using the cloud platform. At the beginning, this is a function that was not available. Now you can do it. We've also brought UT point visualization, meaning you can see all the UT readings inside the model. You can review a scan directly from the cloud. So here again, a very handy tool if you're a lot into thickness measurement and you want to deliver data to a client. This is a very elegant way to do it in a very simple manner. 3D measurement in the 3D viewer, that's also something that was missing initially, and especially now with the textured mesh being available as a guiding layer, it makes a lot of sense to be able to measure in the 3D viewer. We've brought also the ability to manually realign point clouds. Sometimes flights are not exactly aligned the way you want, so you have the ability to move those point clouds in the cloud. And the latest feature we released before colorization is the thermal camera visualization. So you have also the ability now to visualize data, thermal data into your data set. And finally, today we're talking about the colorization feature, which is the latest, the new kids on the block, which I'm really looking forward to see you use. This gives me a quick way to telling a bit what's going to happen next. So I'm not going to go into a lot of details, but let's say we have the intention at FLYABILITY to invest massively into our cloud product to bring new feature and leverage the capability that the cloud brings, which is data centralization, processing power, and eventually the ease of sharing. So we want to build on top of those features, on those capabilities, to bring new features to you in the coming month. And with that, I'm going to hand over to my colleague Gael for his part on the cloud use case. There we go. Gael, on to you.
Fantastic. Thank you, Mark, for this presentation. It's amazing all what we can do with the colorization and the textured mesh, but we also wanted to show you what are the new features and new use cases that customers have developed in the full year of using the cloud, because the cloud is 1 year, as you said. I'm just going to go over 4 different use cases. And we are also very happy to receive your feedback after this webinar, booking a meeting with us to exchange on your specific use cases. But one of the first use cases that people have developed is the capability to sync data between shift pilots that are not working in the same time zone or the same shift, and being able to synchronize all the data from the company through the cloud across all the computers. So that's one of the good use cases for the cloud. Also, some customers are thinking to start using the cloud to go around their own IT limitation. When you have company policies that are restricting use of USB port, you know you cannot use your Elios on your internal company computers, and you use an external laptop. Unfortunately, the data stays on this external laptop. And now with the cloud, you can push your data from the external laptop to the cloud and then back to your local station. So that's also a good usage that people have developed along that year of cloud experiments. On the next slide, Those are the two latest ones we receive, which is something we didn't anticipate it at first, but like the analysis head start you can give to your team by using the cloud. When you have multiple day or even multiple week jobs where pilots capture data in the fields and they can push the data to the office where you have engineers waiting to review the data, if it at lunchtime or the day after, then the analysis starts sooner and your customer gets the result faster. So for big campaigns, that's a huge advantage. And the last one that we've seen a lot of use as well for is the way to secure your data. If you're going on a mission and you have to deliver to your customer, you need to do backup, you need to have your data secured in some sort. You can work with external hard drive, but you can get them lost or stolen. You can do the same thing with a laptop. But as soon as you push data to the cloud, you know your data are safe until you're back to the office and you have time to review and collect them and bring them in a report form to your customer. So that brings you a lot of security and safety to your mission by using the cloud. So that's the 4 cases we wanted to show you. And now we've seen there is a lot of questions in the chat already about how can I get access to colorization? How does it work? So here's a slide gonna answer a bit of it. Every one of you can start using the cloud for free, create your organization, invite an unlimited number of members, connect an unlimited number of drones. It's not linked with a drone. So if you have 5 drones, you only need 1 cloud. The number of asset quantity is also unlimited, even in the free version. With the free version, you're limited by having inspection slot, inspection quantity limited to 2. You have to think that a bit like a parking garage where you have 2 slots for data. And if you remove the data, you can put new data into it. And you can also try the flight colorization and textured mesh as Mark just presented, but with a limited number of 10 flights to be colorized. So try that, try for 10. And then if you think that's something that brings value to you, your customer, or your management, you can go to the cloud-based license, which for you get everything unlimited in terms of flight colorization. You get 100 inspection quantity, which is a lot of spots available to share data internally and also externally with any of your stakeholder, customer, or whoever you want to share the data with. All of that is available. You're welcome to book a free meeting with us to go over your use cases or the idea, the way you want to use the cloud. To start answering some of the questions, some of you have asked if cloud is only, if colorization and textured mesh are only available to the cloud. I think Mark already answered that. It goes together. Colorization and textured mesh go with a cloud base, but it's now an added feature to the cloud without any price increase. So all the current users of the cloud get pretty much the flight colorization for free in addition of the 100 slots they already have. So that's a great feature that we are adding towards the end of this year. So if you want a one-on-one meeting, scan the QR code. And then I think we can go now to the Q&A session.
Thank you very much,
Eloise, maybe you want to take over.
Absolutely. All right, so we've had a lot of questions come through. I've been trying to take notes of all of them. We're going to get through as many as we can. Mark, I think, and Gail, we're going to be testing your technical knowledge to the max. So let's see how we do. So starting out with what should be an easier question is, can we still export the colorized meshes as colorized point clouds?
So there's really a difference between a point cloud and a mesh, right? So the format is different, but so the answer is yes, you can export the textured mesh. The format is GLB. It's quite a specific format, but you can find some converter to bring the information back to a more common format. So that's one thing you can do, and obviously colorized point cloud can be exported as LAS files. So this is something you can do right from the interface. If I just go here and show you, obviously see my screen. So here you have a download button. So here I can download the mesh. Here I can download the colorized point cloud. So it's very, very easy to do. Nothing rocket science here.
All right, perfect. And then, yeah, because building on that, there's been a couple of questions about exporting options. So one of the questions we had from Sam was, what formats can the mesh be exported into? Is it GLB, FBX, or OBJ? I think you've just clarified that.
GLB, yeah.
Perfect.
Yeah.
And then to build on that, then what resolution are the images comparable to, or like what are your results comparable to if you were taking a photo?
So that's again back to what I mentioned earlier. With the meshing, what you see is what you get, right? So if you spend time hovering in front of an object and of interest, and you're very close, you know that the resolution or the ground sampling distance of the Elios 3, when you're at a distance of 30 centimeters or something like that, in the image you see every pixel represents 0.2 millimeter in the real world. Okay, so the resolution is very good, but you need to get those images and you need to get enough so that the algorithm will pick them up and use them for texturing. So here, this feature is not here to ensure an exact, precise resolution, but it's more a tool that is used to give context to your inspection. But you can expect very good resolution inside the textures if you take the time to do it right. Now, keep in mind that I mentioned some of the limitations. There might be some drift. Some images can be slightly misaligned between each other, and this is due both to the drift that we have in the SLAM algorithm of the Elios 3, and also the camera tilting. So this is something that we don't necessarily have characterized, because the goal here is not to be 100% true to reality. It's really to give context. So insisting again on that, because I want to set expectation and not have you disappointed by the results you'll get eventually.
Absolutely. Honesty is the best policy here. Building on what you commented on for drift, there's been a question from Derek who asked, is there a way to ignore a section of the flight? For example, if you only rendered part of your flight on the way, say, down a tunnel, but not on the way back, would that help reduce the drift issue?
That's a good question. So this is not done currently. That's a possible improvement we could do. We haven't done some testing on that, but typically it might be something that can improve. Obviously, we have other technical tracks that we're exploring to improve the texturing. So keep in mind that this feature is brand new, and like everything that is new, it's meant to be improved and subject to further iterations. So we're already thinking about all the things we could bring to the algorithm to make it more accurate, reduce the drift, and so on. So we'll work on that and produce iterations. But obviously, ignoring a part of the flight could potentially improve the texturing. Now, the thing or the side effect of it might be that you might have some holes into the mesh, because some section of your asset will not appear in the field of view of the camera. So what you have to keep in mind is the LiDAR sees a lot more information than the camera. The LiDAR is at the back, it's rotating 360. The camera has a field of view which is limited, and it's always in the front of the drone. So whatever is behind you will appear in the point cloud, but not in the video.
Okay, perfect. Our next question, and I think this one you covered fairly early on, but just to confirm it, was, does colorization work well in dusty environments like grain silos?
Yes and no. Again, if we have some data sets where there is some dust. I don't have it here in the cloud, so I won't be able to pull it up. But basically, we have a tunnel which, in the end, gets very, very dusty. So you barely see anything through the images. Still, we managed to get something out of it. So if you get to very close to the surface, if it's a dusty environment and you get very close to the surface and hover in front of the object, there is a very high chance that one of those images gets picked up for the texturing. So you might get a very good result even then when it's very dusty. But if you stay in the middle of the silo and just turn on yourself expecting the texture to appear nicely, unfortunately, you won't get enough good images to build the texture.
All right, perfect. We're going to go into some questions now about merging flights and merging into a single data set. So the first one is from Vincent asking, can colorized meshes from multiple flights be merged into a single mesh?
So not at the moment. This obviously is, a great improvement that we could do in the future. So for now, the algorithm is limited to one flight at the time. And I can actually show you here. So if I pull up this mesh here from flight one, so let me, okay, so let's even take maybe mesh, number 2. So what's going on? That's the demo effect. Let me switch to another data set. All right. So you see here, I have 2 flights. Both have a mesh, and I have flight 1 turned on. If I turn on mesh 2, all right, there seems to be a problem. So we can only view one mesh at a time. So if you turn on the mesh of another flight, it will hide the other flight. So here, this is what happened in this menu. Obviously, it didn't show up in the viewer, but that's probably Murphy playing with my nerves.
No, it always happens when you're trying to do a demo. I will move us swiftly along so you don't have to worry about it too much. Going through a couple more of the questions we have. Somebody's been asking if the colorized point clouds can be exported to Faro.
No, they cannot be, because Faro Connect doesn't use the point cloud produced by Elios 3 to work. So Faro is based off the MCAP file, or the bag file. Historically, it was called the bag file, and you have this button in Inspector, export to Faro, which produce a specific file, right? And it's not the last file which we use here for colorization. So the answer is no. Now, what we have done, we've done some testing to re-import Faro processed point clouds into Inspector and then to the cloud to colorize them. We managed to do it, and the result is pretty good. It's something we're considering bringing as a standard workflow potentially, so that we could also colorize point cloud that have been processed with Faro initially. But today, no, unfortunately, it's not possible. Not in this version.
Okay, sure thing. There's been a question about tutorial information. So someone has asked if there's a full video tutorial for colored point cloud construction on our system.
So, go ahead, please.
I think for this one, I wanted to jump in, Mark, sorry, but we have a full FAQ available on our website with first a quick start guide on how to use the cloud and create your own account. So that's the first step you should have. And then there's also a full tutorial how to create your first colorized point cloud and textured mesh. And I think this will be added to our follow-up email. That's a good idea for us, I think, Eloise, to include those tutorials in the follow-up email so people have a reference to it.
Yep, I can take a note of that right now. Perfect.
Yeah.
All right, we've got 10 minutes left, so we are slowly running out of our time. So I'm going to try go through our remaining questions as quickly as I can. We've got a good question from Malcolm. This is there a maximum single scan in terms of time? So for example, if somebody was using a tether or even a handheld scan, that can be meshed or colorized?
That's a good question again. So we have tested long flights and handheld scans, and we managed to produce some models. Obviously, there's basically the main driver is the memory, and potentially with very large model, you can run out of memory even on our server, although we oversize them typically. This is something that will, so technically, yes, it can happen. So I don't have a number to say in terms of limits, so please try it out. If it fails, then you'll get an error message. reach out to the support team. And if the reason it's because you run out of memory because your model was too big, so we'll be happy to spend some time and debug and increase the size of the memory so that you can produce a massive model with this tool. So no problem for that. But so far, it's not a limitation we've encountered too many times, to be honest. So, and just adding on the support side of things, we're constantly monitoring those algorithms. So when there are errors happening, we are investigating a bit proactively onto what could be the problem, what could be the reason why a processing would fail. So we might reach out to you and say, hey, look, we know that you had an issue. Would you be okay that we access your data and we check with you how we can fix your problem? So don't be afraid if that happens. We're not spying on you. We're just spying on the, execution of the algorithm just to make sure it's safe and working properly.
All right, perfect. I'm going for our last couple of questions, and I think we've got a few more coming in. I'll try to get to them as soon as I can. I've got one question written down, which I think I've written down correctly, so bear with me, it's a bit of a long one. Someone has asked what products can be downloaded locally. So, for example, image positions and the extracted frames from the video, can they be downloaded alongside a Colorized point cloud and mesh?
So if I understand well, we're talking about generating reports using the functionality. So for now, the report generation, so the export to a Word report, is only available on Inspector. So this is something which you don't have yet on the cloud, and for now we have not leveraged basically the mesh into those reports. So for now, you'll still have to go and do manual screen capture to integrate that into your report. But obviously, this is typically a tool that we want to bring to the cloud and that we want to improve so it leverages the new mesh and the Colorized point cloud.
I think, Mark, you get a very good point saying that everything is also available in Inspector Desktop. You need the cloud to process the data, but all the processed data are then available in Inspector Desktop. So you can do additional POIs and screenshot and put that in your Word report and export a full version of your report with good 3D views from the mesh and everything. So you need to process in the cloud, but you can still use Inspector to generate report at this time.
All right. Perfect. I think with that, we've covered pretty much most of the questions and we're running a little bit short on our time. So I will say thank you very much to Gael and Mark for your presentation today. It's been really, really interesting. And thank you to everyone who's attended for your questions. We will be sending a recording in the next couple of days, and do feel free to reach out if you would like to learn any more. Gael had been sharing his link for one-to-one meetings. We'll also include that in the follow-up email. And I think with that, we can just say thank you for your time and wish you a great end to 2025.
Thank you, everybody. Have a great day.
Thank you very much.
Thank you all.
Have a
Bye.
good day.